Welcome to Scholars Air Tutorial. In this video, we'll be looking at questions under indices. We've talked on laws of indices, and we also looked at some questions under indices in our previous videos. And in this video, we'll be solving more complex questions under indices. Our question 1 says, if 3 raised to the power of y plus x equals 9 raised to the power of x plus y, and 2 raised to the power of x minus y equals 8 raised to the power of x minus 3, find the value of x and y. Question 2 says, solve the equation 2 raised to the power of x plus y equals 8, 3 raised to the power of 2x minus y equals 27. And our question 3 says, square root of 160 r squared plus square root of 71 r to the power of 4 plus square root of 100 r to the power of 8. You can say that square root of this, square root of this, square root of this. You solve this, and you take their full square root. So let's start with our question 1. So our question 1 gave us two terms. If 3 raised to the power of y plus x equals 9 raised to the power of x plus y, and 2 raised to the power of x minus y equals 8 raised to the power of x minus 3, find the value of x and y. So they gave us two terms, this and this. So we'll start by solving for this. After we've solved for this, we'll solve for this, then we'll know the next thing to do. So solving for this, now the first thing we have to do is to express this number 9 in terms of 3, so that both of them will be of the same base. Okay, if we express this in terms of 3, this now will change to 3 raised to the power of 2, because 3 raised to the power of 2 equals 9. So we'll substitute 3 raised to the power of 2 in place of 9. So we'll be having 3 raised to the power of y plus x equals 3 raised to the power of 2 bracket x plus y. Now they are of the same basis. What do? We cancel out, and after cancelling the basis, you can see we are left with the powers. We are left with y plus x equals 2 bracket x plus y. So we write it out. So we'll be having y plus x equals 2 bracket x plus y. After we've gotten this, next thing is to expand this bracket. If we expand this bracket, 2 will multiply everything in this bracket. 2 times x is 2x, 2 times y is 2y. So we'll be having y plus s equals 2s plus 2y. Now that we have this, what is the next thing to do? The next thing to do is to collect like terms. You can see we have x here, we have x here, we have y here, we have y here. So we collect like terms. If we collect like terms, we'll move 2x over to this side. Since it's positive, we change to negative. So we'll be having x minus 2x, and we'll be moving y over to this side because there is y here, and since it's moving over to this side, to change to negative, so we'll be having 2y minus y. So if we do this, we will be having x minus 2x equals 2y minus y. And if we solve correctly, x minus 2s is equals to what? Is equals to minus s, and 2y minus y is equals to y. So we'll be having minus x equals y. Now we've solved for this. Let's solve for this second term. For the second term, we have 2 raised to the power of x minus y equals 8 raised to the power of x minus 3. So like we did here, we express this in terms of 2, so they'll be of the same base. And if we express this in terms of 2, we'll be having 2 raised to the power of 3. So expressing this in terms of 2, we'll be having 2 raised to the power of x minus y equals 2 raised to the power of 3 x minus 3, which is this x minus 3 that is from here. So they are of the same base. What do? We cancel out, and then we write out the powers. So we having x minus y equals 3 bracket x minus 3. Next thing is to expand this bracket. Expanding this bracket, 3 times s will give us 3s, 3 times minus 3 will give us minus 9. So we'll be having x minus y equals 3x minus 9. And the next thing we need to do is to collect like terms. So you can see we have x here, we have x here. So we'll bring this s over to this side and carry over this 9, this y over to this side. for this x to move over to this side, this change to minus, so we're having x minus 3x, and this y moving over to this side change to plus, so y minus 9. And we have x minus 3x equals y minus 9. Solving this, x minus 3x is equal to minus 2x, so we would have minus 2x equals y minus 9. So now we are supposed to call this one equation 1, and we call this equation 2. Also, if you look at this side, you can see that our y means y is equals to minus x, same way minus x is equals to y, and here we have minus 2x equals y minus 9. So what we have to do is to substitute this value of y minus s into this. So here we are having minus x, here we are having y, we'll change to minus x, and we will be having minus 2x equals minus x minus 9. Now we'll take this x to the left hand side, since they are like terms, take like terms, and we'll be having minus 2x plus x equals minus 9. Minus 2x plus x will give us minus x, so this will give us minus x equals minus 9. Now this is, there is negative sign, there's negative sign here, so we cancel the negative sign and we have x as 9, so x equals 9. So now we found the value of x. Recall the question says find the value of x and y. Next thing is to find the value of y. And recall here in our equation 1, it said that minus x equals 9 equals y. Minus x equals y. So y, since y is equal to minus x, and we found that the value of x is equal to 9, so what we just have to do is add minus to this x. Adding minus to this x means adding minus to 9, so our y is equal to minus 9. So we have the value of x as 9 and the value of y as minus 9, and we are done with this question. So this is how we can solve question 1. Let's look at question 2. Question 2 says solve the equation 2 raised to the power of x plus y equals 8, 3 raised to the power of 2x minus y equals 27. So what they are also trying to tell us to find the value of x and y. Same thing we did here. So I would have said let me leave this one for you guys to do, but let's just solve it together. So like we did here, we'll solve for the first term, solve for the second term, and then we know what next to do. Solving for the first term, 2 raised to the power of x plus y equals 8. We express this 8 in terms of 2 so that they will be of the same base. Expressing this 8 in terms of 2, we have 2 raised to the power of 3, and since they are of the same base now, we cancel out. After cancelling, we take what's remaining, which is the powers. So you have x plus y equals 3, and we call it equation 1. Now over to the next term. So we have 3 raised to the power of 2x minus y equals 27. We express 27 in terms of 3. Expressing 27 in terms of 3, we have 3 raised to the power of 3, because 3 raised to the power of 3 will give us 27. So we'll be having 3 raised to the power of 2x minus y equals 3 raised to the power of 3. They are of the same base now, so we cancel out. And we pick what is left, which is the powers 2x minus y equals 3. And we call this equation 2. So what is the next thing to do? The next thing to do is to solve equation 1 and equation 2 simultaneously. So let's write out our equation 1 and equation 2. So we have x plus y equals 3 as our equation 1. 2x minus y equals 3 as our equation 2. How can we solve this simultaneously? We have y here, we have y here, so they are equal, but they are having different signs. This plus here, this minus here, so we cancel this out, we cancel this y out, but since they are having different signs, we add. If they were having the same sign, we would have subtracted, but for the fact they are having different sign, we add. What do we add? We add equation 1 and 2. So within x plus 2x, we've already cancelled out this y. So s plus 2x 3 plus 3. So we are having s plus 2s equals 3 plus 3. Now if you don't understand simultaneous equation, I will do a video on simultaneous equation where we're looking at different ways of solving simultaneous equation. This particular one I just did now is what we call elimination method. We call it elimination method. We have the substitution method. The substitution method is actually what we use in this question 1. Do I not state it out? So I'll do a different video on simultaneous equation and how to solve simultaneous equation. Now we are having s plus 2s. S plus 2s is what? 3x. 3 plus 3 is 6. So we are having 3x equals 6. And since we have 3s equals 6, how can we find s? The next thing to do is to divide. We divide both sides by 3, which is the coefficient of x. Dividing both sides by 3, 3 into 3 is 1. So 3 we cancel 3. 6 divided by 3 is 2. So our x equals 2. So therefore our x equals 2. Now we found the value of x. Let's find the value of y. Looking at equation 1 and 2, which of them will be easier to find y? So we'll be using equation 1. So next thing is we'll be substituting the value of x, which is 2, into equation 1. So we have x plus y equals 3. Substituting the value of x, we have 2 plus y equals 3. Next thing to take like terms, we'll carry this 2 over to this side. Taking this 2 over to this side, we'll be having y equals 3 minus 2, and 3 minus 2 is what? 1. So the value of our x is 2 and the value of our y is 1. You can also verify this. To verify this, look at the initial question. We have 2 raised to the power of x plus y equals 8. Now we say x is what? 2. So we have 2 here. Y is 1. We have 1 here. 2 plus 1 is 3. So 2 raised to the power of 3 is what? 8, which is very correct. So our answer and our solution is very correct. Let's see how we can solve question 3. So for our question 3, it says square root of 160r squared plus square root of 171r to the power of 4 plus square root of 100r to the power of 8. I decided to use a fresh page because I needed to enlarge this stuff and I want you all to see the solving, full solving. So let's start with this question 3. I guess to you all is looking very complex. You are thinking, where do we start from? So this is it. To start, we need to start from here. After solving this, we'll solve for after solving for this square. Let me not say this. After solving for this square root, we solve for this square root and we solve for this square root. So solving for this square root, we have 100r square root of 100r to the power of 8. Now what do we do from here? Recall I said square root also means raised to the power of 1 over 2. Whenever we have square root, it means raised to the power of 1 over 2. So we'll be writing this in terms of power and no longer square root. So we'll be having 100r to the power of 8 all to the power of 1 over 2. Now recall the power law of indices. What we just have to do, we have to apply that law here. Applying that law here, what we just have to do is take this as an individual power. So we have 100 to the power of 1 over 2, r to the power of 8 to the power of 1 over 2. And recall we say them in the power law of indices. When we have a power inside the bracket and outside the bracket, we multiply the two powers. So multiplying this and this, we have 8 times 1 is what? 8 divided by 2. 8 divided by 2 is 4, so you have r to the power of 4. But first of all, let's express this first. So we are having 100 to the power of 1 over 2 into r to the power of 8 to the power of 1 over 2. Now look here, we say that whenever we have anything to the power of 1 over 2, that also means the square root. So we'll bring this 1 back to square root. So we'll be taking square root of 100 times r raised to the power of 8 to the power of 1 over 2. So we are having square root of 100 times r raised to the power of 8 to the power of 1 over 2. And we said for this, remember the power law, we multiply these two powers. And 8 times 1 over 2 is 4. So r to the power of 4. And if you have r to the power of 4, square root of 100 is what? Is 10. So we're having 10 times r to the power of 4. And 10 times r to the power of 4 is what? 10 r to the power of 4. So we finished studying for these square roots. Next thing is, since we've gotten the value of these square roots, which is 10 r to the power of 4, we place it here. So if we place it here, we have something like this: square root of 160 r squared plus square root of 71 r to the power of 4 plus 10 raised to the power of 4. So you can see this one and this one, they are both r to the power of 4, r to the power of 4. So 71 r to the power of 4 plus 10 r to the power of 4 will give us 81 r to the power of 4. So we'll be having something like this: square root of 160 r squared plus square root of 81 r to the power of 4. So next thing is, we solve for the value of 81 r, square root of 81 r to the power of 4, just the same way we did here. Is we also apply it here. Solving for this 81 r to the power of 4, square root of 81 r to the power of 4. Recall I say whenever I have square root, we express in terms of power, and expressing this in terms of power, we have 81 r to the power of 4 all raised to the power of 1 over 2. This 1 over 2 means the square root. So we are expressing in terms of power. And if we have this, recall the power law. Same thing we did here. We take 81 to the power of 1 over 2 and r to the power of 4 to the power of 1 over 2 individually. And if we do this, we have 81 to the power of 1 over 2 bracket into r to the power of 4 to the power of 1 over 2. And recall I said anything to the power of 1 over 2 means square root of that thing. So we express this one back as square root. So we'll be having square root of 81 times r to the power of 4 to the power of 1 over 2. Now square root of 81 is what? Is 9. So here we have it as 9, and r to the power of 4, we recall power law. So the power inside the bracket and outside the bracket, you multiply it. 4 times 1 over 2 is what? Is 2. We say 4 times 1 divided by 2, so it's 2. So we are having 9 times r to the power of 2, and 9 times r to the power of 2 is what? Is 9r squared. So we have 9r squared. Now recall when we solved this one, after solving this, it gave us r to the power of 4, which was this thing attached to 71. Now we've solved for this, and it's giving us r squared, which is the same thing attached to this other 160. So as you are solving, it's giving you the value to solve this, and it's solved to give you the value to solve this. So at least from here you should start having an idea on what next to do. So the next thing, we bring this back here. So we'll be having square root of 160 r squared plus 9r squared. Now if we add these two, because this is r squared, this is r squared, so we can add. If we add these two, we are having 169. So we have square root of 169 r squared. And same thing we did here, same thing we did here, the same thing we'll be doing here. So it's just a repeated process. So 169 r squared, we express this in terms of power, meaning we'll be having 169 r squared to the power of 1 over 2. And if you recall the law of indices, the power law, we express this individually as power. So we'll be having 169 to the power of 1 over 2 into r squared to the power of 1 over 2. And we bring this one back as square roots. So we'll be having square root of 169 times r squared to the power of 1 over 2. So square root of 169 is 13, and r squared to the power of 1 over 2, power law, 2 times 1 over 2 is 1. So anything to the power of 1 is still the same thing. Or you can do 2 times 1, which is 2 divided by 2, is still 1. So r to the power of 1 is r. So we'll be having 13 times r, and 13 times r is what? 13r. So this is our final answer. You can see that this 13r is the final answer for this whole stuff here. So if you follow the steps accordingly, you'll be able to arrive at the final answer, final and correct answer. So if you enjoyed this video, make sure you subscribe, like and comment.